What is an event stream, or simply, stream? A stream is a sequence of events. A stream is often ordered by time but can also be unordered. A stream is append-only, one cannot remove events, one can just add them to the sequence. A stream is unbounded, i.e. there is no end to the sequence. Streams are the basic building blocks of event processing. Similar to functions in a functional programming language, event processing treats computation as the evaluation of streams. Streams can originate from real-time currently produced data or from a replay of historical recording. Stream and event type is effectively the same in Esper. Streams in Esper have zero cost in terms of memory or processing. You could register millions of streams. This is because a new stream is simply a new event type and does not by itself cause events to be processed. The right side of the slide shows a picture with a vertical time axis. The picture illustrates that events arrive and time passes, and depicts the output. To the left of the vertical time axis, under the title, Incoming Events, are arrows that depict events arriving. To the right of the vertical time axis is output. There is a box for Update Listener, which is simply the object receiving output. An update listener can receive new and old events. Under the title, New Events, and Old Events, is output. We explain old events output later. Let's focus on the left side of the slide now. The stream of new events is called Insert Stream. The insert stream consists of the events that an application sends into the runtime and also those events generated by other EPL. Consider the following EPL statement. Select star from withdrawal. Let's say we are a banking application tracking checking account transactions. A withdrawal event reflects an account withdrawal transaction. A withdrawal event has an event property named amount. The W1 parenthesis 500 is short for withdrawal event 1 with an amount of 500. The W1 is short for withdrawal event 1. Update listeners and subscribers receive output. The update listener interface receives the new events, old events, statement and runtime. Look at the picture on the right side. Assume there is a stream of withdrawal events arriving into the Esper runtime. When withdrawal event 1 with amount 500 comes in, the output is the same withdrawal event 1. This example outputs the same event instances as the incoming event because the EPL has a select clause, select star. If the select clause was different, the output would be different. When withdrawal event 2 with amount 100 comes in, the output is the same withdrawal event 2. When withdrawal event 3 with amount 200 comes in, the output is the same withdrawal event 3. And so on. This slide introduces data windows. Data windows define the subsets of events to consider. Here, we discuss the length window, that is a data window that keeps the last n events. Consider the following EPL statement. Select IR stream star from withdrawal at length parenthesis 5. The at length 5 defines a length window of 5 events. This means the runtime will consider the last 5 events only. This example EPL also uses the IR stream keyword. The IR stream keyword outputs both the insert and remove stream. Without the IR stream keyword, the output is only the insert stream. Remove stream is the name for events that are no longer considered. Please take a closer look at the picture now. When withdrawal event 1 with amount 500 comes in, the Esper runtime keeps the event in the length data window, and the output is the same withdrawal event 1. When withdrawal event 2 with amount 100 comes in, the data window also retains that event and the output is the same withdrawal event 2. When withdrawal event 3 with amount 200 comes in, the window again keeps that event, and the output is the same withdrawal event 3. Now there are 3 events in the window. When withdrawal event 4 with amount 50 comes in, the window keeps the event, and the output is the withdrawal event 4. When withdrawal event 5 with amount 150 comes in, the window keeps the event, and the output is the withdrawal event 5. At this point the data window is full as it has 5 events. Finally withdrawal event 6 with amount 300 comes in. Since the data window only keeps the last 5 events, the runtime removes withdrawal event 1 from the data window. The output is withdrawal event 6 in new events, and withdrawal event 1 in old events. As more events arrive, you can see that there will be a stream of withdrawal events that get removed from the data window starting with withdrawal event 2, then 3, then 4 and so on. These expired events constitute the remove stream. Filter expressions filter events from a stream. The example EPL statement for this slide is: select star from withdrawal parenthesis amount greater or equals 200 at length parenthesis 5. The example filter expression is amount greater or equals 200. The filter applies before events enter a data window. The Esper runtime ignores events that do not satisfy filter expressions. The Esper compiler analyzes filter expressions extensively. The compiler performs index planning and optimization, making sure that the runtime can match incoming events to statements efficiently. The right side of the slide is a picture that shows withdrawal events arriving on a time axis. When withdrawal event 1 with amount 500 comes in, since the amount value of 500 satisfies the filter, 500 is greater than 200, the runtime adds withdrawal event 1 to the length window and outputs withdrawal event 1. When withdrawal event 2 with amount 100 comes in, since the amount value 100 does not satisfy the filter, 100 is less than 200, the runtime ignores the withdrawal event 2. When withdrawal event 3 with amount 200 comes in, since the amount value 200 satisfies the filter, the runtime adds withdrawal event 3 to the data window and outputs the withdrawal event 3. When withdrawal event 4 with amount 50 comes in, since the amount value of 50 does not satisfy the filter, the runtime ignores the withdrawal event 4. When withdrawal event 5 with amount 150 comes in, since the amount value 150 does not satisfy the filter, the runtime ignores the withdrawal event 5. When withdrawal event 6 with amount 300 comes in, since the amount value 300 satisfies the filter, the runtime adds withdrawal event 6 to the data window and outputs the withdrawal event 6. And so on. This slide introduces aggregations. Aggregations collect a set of values to return a single value. This example discusses the count star aggregation function that returns the number of rows. The slide compares the output between two EPL. The first EPL is simply select count star from withdrawal. It does not define a data window. The second EPL is select count star from withdrawal at length 5. It defines a length window of 5 events. In the table, under the event column, there are the withdrawal events. Under the output column is the respective output of each EPL. When the withdrawal event with amount 500 comes in, both EPL output a count of 1. When the withdrawal event with amount 100 comes in, both EPL output a count of 2. When the withdrawal event with amount 200 comes in, both EPL output a count of 3. When the withdrawal event with amount 50 comes in, both EPL output a count of 4. When the withdrawal event with amount 150 comes in, both EPL output a count of 5. Finally, when the withdrawal event with amount 300 comes in, the EPL outputs a different value for count. The output for the EPL without the length window is a count of 6. The output for the EPL with a length window is a count of 5. Both EPL keep a count. Note the length window of 5 events does limit the count to 5. Only the EPL with the at-length data window retains any event instances. A EPL without a data window never retains events, unless using patterns etc. A time window is a data window that manages events by time. For instance, select from withdrawal at time parenthesis 4 seconds. The single parameter of a time window is a time duration. The time window removes events from the window that are older than the time duration. So, a time window of 4 seconds means that the time window removes events that are older than 4 seconds. We discuss how time advances later. A runtime has a scheduling component that tracks filled time windows. Therefore, when a time window is empty, the runtime does not do any kind of tracking or processing at all. And when time advances but no events expire, there is no processing at all. The time tracking of a time window is based on runtime time. Runtime time is a global concept and passes in milliseconds or microseconds. The picture on the right side has an example scenario. Assume that at time t plus 4 seconds, withdrawal event 1 arrives. The runtime allocates a time window and adds the event to the time window, and outputs the withdrawal event 1. Since the withdrawal 1 event arrived at time t, the time window logically tracks events between t and t plus 4 seconds. Assume that at time t plus 5 seconds, withdrawal event 2 arrives. The runtime adds the event to the time window, and outputs the withdrawal event 2. At that point the time window logically tracks events between t plus 1 seconds and t plus 5 seconds. Assume that at time t plus 6.5 seconds, withdrawal event 3 arrives. The runtime adds the event to the time window, and outputs the withdrawal event 3. At that point the time window logically tracks events between t plus 2.5 seconds and t plus 6.5 seconds. At time t plus 8 seconds the withdrawal event 1, which arrived at time t plus 4 seconds, is 4 seconds old. The time window removes the event from the window and the runtime outputs withdrawal event 1 as an old event. And so on, with time advancing, the time window removes events as they get older than 4 seconds. For batching up events, one can use a batch window. But, later, in the training on context definition, you will learn more powerful techniques for controlling batching. The EPL for this example is, select from withdrawal at time batch parenthesis 4 seconds. The single parameter of a time batch window is a time duration. The time batch window collects events and outputs batches based on time advancing. The output is a batch of new and old events. The prior batch is the old event output. Instead of batches, we recommend to use the more powerful context definitions, which we discuss in later material. So, in this example, the output of the time batch window of 4 seconds is all events that arrived in the last 4 seconds, and all events that arrived in the previous to last 4 seconds. The picture on the right side is for illustration. Assume that at time t plus 1 seconds, withdrawal event 1 arrives. The runtime adds the event to the current batch, which we assume started at time t, and does not output the event. Since we assume the batch started at time t, the batch window logically tracks events between t and t plus 4 seconds. Assume that at time t plus 3 seconds, withdrawal event 2 arrives. The runtime adds the event to the current batch and does not output. At time t plus 4 seconds the runtime concludes the current batch and outputs withdrawal event 1 and withdrawal event 2. Assume that at time t plus 6.5 seconds, withdrawal event 3 arrives. The runtime adds the event to the current batch and does not output. At time t plus 8 seconds the runtime concludes the current batch and outputs withdrawal event 3 as new events. It also outputs the previous batch, withdrawal event 1 and withdrawal event 2 as old events. And so on, with time advancing, the batch window collects 4 seconds of events and only outputs at the end of the 4 seconds. Every 4 seconds the runtime outputs the current batch as new events and the previous batch as old events. The next 4 slides are about the EPL event processing language. EPL adheres to the SQL standard, and if you are familiar with SQL it helps. Many EPL statements select data from one or more streams of events. To select data, the EPL must have a select clause, and a from clause. The slide shows a summary of the keywords that make up the EPL that selects data. In light blue are the keywords. For example, insert and into are a keyword, and select is a keyword, and from is a keyword. In the summary, square brackets indicate when a clause is optional and can be left off. The insert into has square brackets since insert into is optional and you can form an EPL select without insert into. You can use insert into to output the results as a stream. The select clause is required. The select clause lists the event properties, aggregations or other expressions that are part of the output. The from clause is required. The from clause lists the event type names and data windows. Remember, event type names and stream names are the same. The where clause is optional and typically has correlation expressions. The group by clause is optional and is applicable when using aggregations. The group by clause collects data across multiple events and groups the results by one or more event properties. The having clause is optional and is applicable when using aggregations. The having clause is for conditions that filter which group results appear in the results. The output clause is optional and is used to specify an output rate. The order by clause is optional and orders output when there are multiple output rows. As we have seen in the earlier slides, often there is only a single event in the output and therefore the order by clause is not used that often. This sample EPL selects aggregated withdrawal events. This sample EPL starts with comments. Single-line comments have a // at the beginning of the line. After the comments is the select clause. Here we select the account and the total amount. The sum aggregation function returns the total per group. After the select clause is the from clause. Here we specify that we want to analyze the last 1 minute of withdrawal events. The group by clause is next. The total should be per account and therefore the group by clause has the account ID. The having clause is next. Since we only want to see accounts that have a total greater than 1,000, the having clause compares the total. Thus, this EPL totals up the withdrawal amount per account ID, considering the last 1 minute of withdrawal events, and outputs only those accounts that have a total withdrawal amount greater than 1,000. The previous slides have discussed the insert stream, which are newly arriving events, and the remove stream, which are old data. It is often useful to get a remove stream, because it indicates changes compared to the last output, such as the prior aggregation values when selecting aggregations. By default the runtime only outputs the insert stream. The I stream keyword outputs the insert stream only. The IR stream keyword outputs the insert and the remove stream. The R stream keyword outputs the remove stream only. This slide is about the from clause. The from clause syntax starts with the event type name. When discussing syntax, the square brackets enclose optional parts. After the event type name you may provide filter criteria expressions in parentheses. Since the filter expressions are optional in the syntax they are in square brackets. After the filter expressions you may provide data windows, again optionally. The event type name of our sample events from the previous slides is withdrawal. For instance, say withdrawal, without filter expressions and without a data window, to select all withdrawal events. For instance, say withdrawal with amount greater 200, without a data window, to select all withdrawal events that have an amount greater 200. The amount greater 200 expression filters withdrawal events and ignores those that have an amount less or equal to 200. The Esper compiler analyzes filter expressions like amount greater 200 and plans and optimizes to become fast at matching incoming events to deployed EPL. For instance, say withdrawal with amount greater 200, considering the last 10 seconds of withdrawal events that have an amount greater 200. The time 10 seconds is for a 10-second time window. So this will consider the last 10 seconds of withdrawal events with an amount greater 200. As you can see, it is not necessary to use data window at all. In fact, don't use a data window unless you need it. Pattern matches are also streams and are therefore in the from clause. We'll learn about patterns later on. This example pattern selects withdrawal and deposit events. The from clause can have other things than just event type names. The from clause can have an SQL query, for use with a database that understands SQL. The from clause have also invoke application predefined methods for returning data stored elsewhere. The from clause can access named windows and tables. Named windows and tables are for sharing events and data across the runtime, and we also learn about these later. The from clause can list multiple event types as a join. We have a short discussion about joins here as we are discussing the from clause. Joins are a great way to analyze data and they are a valuable tool besides patterns, subqueries etc. A join outputs rows when events of either stream arrive. The material has more information about joins later on. Shown here is an EPL that joins the trade events and settle events. It is an example coming from the financial domain that handles trades and settlements for orders. The select clause has a select star. This means that the output contains the events of both streams. In a moment we'll talk about the output in more detail. The from clause considers the last 30 seconds of trade events with a symbol, IBM. There is the as keyword here. The as keyword here assigns a name to the stream and that name is only relevant for that EPL select. For the trade events, the as keyword assigns the name, TE. The from has a comma. After the comma it lists another event type. The second part of the from clause looks for the last 30 seconds of settle events with a symbol, IBM. For the settle events, the as keyword assigns the name, SE. The where clause correlates the two streams by order, ID. Since we assign the name, TE, to trade events, the where clause can say, TE.order, ID, to mean the order, ID, of the trade event. Since we assign the name, SE, to settle events, the where clause can say, SE.order, ID, to mean the order, ID, of the settle event. The output of this join query is each matched pair of trade and settle events combined into an output row. A result row has two columns. The TE column in the output is the trade event. The SE column in the output is the settle event. A join outputs rows when events of either stream arrive. When a trade event arrives, the runtime finds the matching settle events and produces output if it can find matching settle events. When a settle event arrives, the runtime finds the matching trade events and produces output if it can find matching trade events. Applications can query the current result of joins using the pull API that we elaborate later. Joins support outer joins. This example was an inner join. There is a very handy, unidirectional keyword that can control which stream triggers output. The insert into keyword produces output into a stream. The output keyword states the output rate. This EPL uses the insert into keywords and the output keyword. The example is from the stock trading domain. It computes an average price per symbol on the last 10 minutes of stock ticks. The insert into tells the runtime to output the result into a stream named simple moving average. Other EPL can use that simple moving average and select it, or aggregate further, or do pattern matches on the stream, etc. Observe that there is a comment in the EPL. The comment starts with /* and ends with */. Comment like this can be handy to add explanations to the EPL. Note the use of the as keyword in the select clause. It assigns the name average price to the result of the average aggregation function that has price as a parameter. This makes sure that the output has a column named average price that holds the average. The output all every 1 minute tells the runtime to output all symbols and averages every 1 minute. By default and without the output clause, the runtime would output every time there is a new tick event. Like we have seen in prior material, every time there is an input stream event, there also is output, unless there is an output clause. The second EPL selects from the stream populated by the first EPL. Select average price from simple moving average. The output keyword controls the output rate and also the output content. Use output all for all available rows. Use output first for the first row or rows. Use output last for the last row or rows. Use output snapshot to output according to the data window, when a data window is specified. After the every keyword is a rate and a unit. The rate is a number and the unit can be minutes, seconds, events or a time period. There are 2 free tools for running EPL available online. The notebook is at https://esperonline.net. The notebook is a notebook-style application. The second application is a Google Cloud Web application. The URL is provided here. Both tools use the same format for event input. The format consists of the event type name, then an equals character, then curly braces, and then a list of event property names and values. For example, withdrawal event equals ACCT ad equals 123, amount equals 10. Each event must fit into the line. The tools don't support multi-line events currently. Spaces are optional and strings are quoted or double quoted. Both tools can advance time. The format for advancing time is d equals d plus parenthesis time period. For instance, d equals d dot plus 5 seconds. The tools also have a documentation button.